Hey, Shoaib. Hello. Can you
Yeah,
hear me?
hi.
Hey, Shoaib. Hey, Ranjit.
Yeah, hello. Hi. Hi. How are you?
Good, good. Shoaib. So just give me 2 minutes. We'll start.
Yeah, sure.
Okay, let us start. Maybe others will join. I pinged in the group. I hope Shoaib and Ranjit, you are new to the class today. I'll just give a high-level overview on Snowflake, and then we'll move forward.
Sure.
I'm just sharing my screen. Let me be able to see. Just to get an idea, Shoaib, any high-level introduction about yourself, your background, just to at a very high level.
Yeah, Shri. Thanks for the opportunity. So my name is Sheikh Shoaib. I have over 6 years of experience in the IT industry, mainly into big data Hadoop administrations.
Mm-hmm.
And after that, I got opportunity for Kubernetes
Okay.
administration with supports. Currently, I am focusing on transition into Snowflake role. So I have been on a break since last year, 2024 July, due to health
Mm-hmm.
issue. So, but now I
Okay.
am fully recovered and actively preparing for the new opportunity in the cloud data platform space.
Okay. Okay. So you are looking for specifically Snowflake roles, correct? No.
Currently it's Snowflake. I can say, but I need to investigate more. So yet I haven't decided. But after that this session, I will decide whether should I go or not because I am not aware fully aware. I don't have fully awareness on the Snowflake.
Okay. Okay. No problem.
Yeah,
That's
yeah,
fine.
sure. Thank you.
Okay. Okay. Ranjit, over to you at high level.
Yeah, Shri. Hi, everyone. So my name is Ranjit. I'm working as an change manager from last 7 years. So currently, I'm looking for a domain change since it was like a routine day-to-day activity since I'm doing from the past 7 years. So I just wanted to change the domain since SQL is having some more opportunities in the IT. So I wanted to change it from
Okay.
change management to the Snowflake. Yeah.
Okay. Cool. Cool. So the Pujita is already she's a part of the classes and she's also learning Snowflake to seize the job.
Mm-hmm.
And so let us start today's class. So I'm
Sure.
sharing my screen. Let me know you're able to see. So coming to me, I have nearly 20 plus years of experience, and I am currently working as a Snowflake architect and in a multinational investment firm. And I majorly work on building data pipelines and manage Snowflake environments, and also go and build data science applications on top of that by leveraging the Python, Snowpark, and also Snowflake administration part. Also, I'm working on some part of. And coming to data warehouse. So Snowflake is a very buzz term now in the market. And if you go and see, majority companies are looking for Snowflake developers, plus as well as who know some administration part as well. But why Snowflake? So Snowflake is a cloud data warehouse. And before jumping into data warehouse, let us try to see what Snowflake is. We'll discuss about. But when I talk about data warehouse, so data warehouse is basically the term is not new. Whenever you see like in the early 2000s, the most of the companies were when they were busy in centralizing their data. The data was in databases like Oracle SQL Server and other databases, and people started thinking like how to analyze the data. The real-time environment was not supportive because the data will be most frequently changing. So everybody started like looking for an alternative method to perform the analysis. So the solution for that is a data warehouse where people started separating the historical data into another database and only keeping the past data, and that has been people start calling as data warehouse. The conventional data warehouse was is burned in early 2000s, and Informatica and data stage SSH, these tools were very popular that time to build these data warehouses. And on top of that, if at all you want to generate any reports, Power BI was one of the Crystal Reports was one of the a popular reporting service, and business objects and MicroStrategy and SQL Server reporting services. All these were people leveraging for the business intelligence reports. And sources for this particular data warehouse also was internal products and also some part of the CRM applications of the enterprise companies. And even structure of the data also was in this particular data warehouses was only rows and columns structure. there was no any semi-structured, unstructured data in 2000s decade. And what knowledge is required to build this data warehouse was SQL and PLSQL if you are working on Oracle data warehouse, and if you are working on SQL Server, you as a ETL developer, you should know SQL Server side TSQL. And even the data loading, when I say data loading, when we are loading from the real-time environment to this data warehouse, you need to follow a batch process before 2010 in 2000 decade, because the data, whenever it is ready after business hours, then companies to load that into the conventional data warehouse by running some batch jobs, because during the business hours you can't go and use that because it will be used by most of the business people. So this is how the conventional data warehouse was born, and people started leveraging this data warehouse for most of the analytics part. But whenever we moved to like 2010 decade, there was a big revolution in the data side with big data like has been invented. Every company started experiencing huge amount of data because of social media and other applications, and the most of the unstructured data was generated during this time period, like semi-structured, unstructured, quasi-structured, all became part of the data warehouse. And slowly data warehouse has been converted to big data warehouse because of data volume and also data varieties and data velocity. So people started experiencing these challenges. Then Hadoop came into the market. The HDFS plus MapReduce. HDFS for storing the data and MapReduce for processing the data. These two tools became the one of the biggest solutions for processing the big data and building the big data warehouse. On top of that, the data lake as well. So data lake is nothing but a data warehouse with live streaming data. So every company started building their own big data lakes, and by leveraging this particular MapReduce and HDFS, slowly MapReduce was having some limitations. People moved to Spark, and MicroStrategy and Power BI. These two tools became popular in the business data space because big data came into the market. Companies also started looking for new BI tools. So Power BI got invented, and the sources also became structured, semi-structured, and also social media also became one of the part of the source, unstructured data majorly. And to manage this, we need to have a big data environment. That is where companies started investing more on big data and especially Hadoop environments. And people who wants to work on this particular data warehouses or data lakes mostly requires Java here. So that was one of the biggest challenge for people to migrate to big data environment. Slowly, after some time, what happened? Scala came into the market with Spark, and now market is running behind PySpark. Python Spark is the popular framework now to process the big data on the Hadoop environment. And the data loading frequency also, before 2010, people were only focusing on batch data. As soon as we moved to the 2010 decade, companies started experiencing large amount of data, also want to build like a real-time analytics and real-time recommendation systems and real-time fraud detection systems. So to manage these applications, we need live data. So the live data will be like streaming data. So big data tools for helping to even manage streaming data as well. So big data warehouse has been converted to big data lake. A data lake or big data lake is a location where you have a continuous flow of data, like a continuous flow of water, how it will be in lake. You will have a continuous flow of data in a data lake. So all these companies were experiencing and successfully able to even build these big data warehouses. But the challenge what a developer or a company's the experience is a developer's perspective. If you go and see, every developer need to go and understand and learning these many frameworks if you want to become a big data engineer in 2010 decade. To maintain a big data environment or a big data lake, you need to know all these frameworks, most of these frameworks, because data will be coming from multiple sources. To centralize that in the Hadoop HDFS environment, you need to learn these many frameworks, which is very, very one of the biggest challenge for the developers. Similar to that, companies also start experiencing the challenges to maintain these big data environments because maintenance is very hard, patching, upgrading also is very hard. Every month, new release will be come out, and companies need to have a dedicated team to perform this administration part, specifically Hadoop administration. And also you can go and see finding a administrator with Linux administration knowledge in big data side is not easy. So even every company started experiencing these challenges, and also they are unable to reuse the existing people who are already working on conventional data warehouse. People were not ready to move to this particular big data environment because of the high learning curve. Even rare resource, if at all you want to go and hire, you need to pay high salary as well. So this kind of challenges every company experienced during the big data era. I hope so. Shoaib has to tell. Shoaib, you are working on big data side, right? Shoaib, that will come down.
Yes.
So you might have seen administration part is not that much easy, right? In Hadoop side, not
Yes. Yes.
everybody. So you need to know some Linux administration part also, and every developer cannot go and act as an administrator. A administrator can act as a developer. That is the one of the biggest challenge. And even to
Yes.
maintain this environment, we can imagine how much infrastructure is needed. And we need to have a dedicated team also, very, very important here. So that is the one of the biggest challenge for companies as well as even developers also. So whenever the data warehouses having this particular challenges, slowly cloud tools came into the market. Like AWS started providing solutions like EMR. So EMR Spark cluster you can create within 10 minutes without depending on any administrator. So that is one of the biggest revolution in the big data side. So we have so many services which this cloud services, cloud leaders provided to automate this particular like big data management also. So slowly new cloud tools came to the market, which are like Snowflake came to the market, Amazon Redshift, Google BigQuery. All these became slowly the leaders in the database, cloud databases in the respective cloud environments. The main reason why companies move to this cloud databases is flexibility, and also saving the cost, pay as you go, and saving the cost, and accessibility, and where we can easily access from any device anytime during from any location. And most companies attracted with this particular pricing part only, pay as you go, and then accessibility and availability and flexibility. So Snowflake also started providing these kind of features. So Snowflake became next generation of big data because to learn big data, because we know we need to know some part of at least Java, Scala, or Python. But for Snowflake, we do not need to know even any kind of these languages. If you know SQL, that is more than enough. And even for Python, we use for very extreme use cases, we go and use Python. If you know a basic SQL and very basic level of data warehousing fundamentals, you can easily learn Snowflake. Second thing, Snowflake and big data both can manage structured, semi-structured, and unstructured. Snowflake was not supporting unstructured. Now they are supporting unstructured also with the new features and releases. And live data streaming, usually we go and use Kafka in big data environment like Kafka or Flink, or we also have other big data cloud framework like Kinesis. These particular tools are required to maintain the live data streaming environment. But same Kafka connector can be used in Snowflake also, and I can build a big data lake in Snowflake by connecting and using Kafka connector and manage my live environment as well. And the stability wise, if you see big data ecosystem is very fragile, it will be keep on changing, and every month you get new releases for every framework, and you should know how to go and manage, and your team should know how to maintain the environment, and you have to hire a dedicated team. But in case of Snowflake, there are no any requirement to go and maintenance and all, because the features are all integrated in a single product, and even the patching, upgrading, and the provisioning, everything will be taken care by Snowflake team, not we. But in case of big data ecosystem, we need to take care of optimizing or upgrading the environment and the even the tools, right? So because most of the big data environments, if at all I want to go and maintain, I need to keep on monitoring the environment, and any new changes required, we need to go and perform this particular upgrades and uh, release management, everything. And coming to like a performance optimization side, Snowflake side is inbuilt. There is no requirement for manual optimization. But in case of big data side, definitely you need to have a manual intervention, and the right need to go and optimize from the memory perspective, storage perspective. We definitely need to do some kind of manual performance optimization. And the transformation side, definitely you need to go and write some PySpark scripts here in big data environment. But in Snowflake side, if you see, we do not need to write any code, and you can experience or leverage the GUI tools already available in the ETL space. Like DBT is very popular now, Snowflake DBT, which we are going to discuss as part of this training, and Informatica IICS and Matillion, stream sets. Most of these tools, CTL is a new tool, and also like Fivetran. All these new frameworks are already invented, and the people started leveraging these tools to manage Snowflake data from their environment. Like for example, earlier Informatica and Oracle was the combination. Now Matillion and Snowflake is the combination, or DBT and Snowflake is the combination, or stream sets are Snowflake. So Snowflake has multiple partners. So we can use any of these tools and manage Snowflake data and perform the data ingestion as well. And coming to like supported sites, both Snowflake and big data will like support like unlimited. And in big data side, you have a restriction on the on-premise based on the size. And even for cloud also, it is near infinite. We are going with a cloud big data environment. But Snowflake side, it is by default unlimited, because it is infinite storage. They will not restrict you on the storage side. And resource availability also, big data side, definitely it is not easy to find, because
Sorry to interrupt. So just want to know what is meant by ingestion, and how
data
the
loading.
DBT or other tools will help for the
Correct.
Snowflake.
Okay,
When-
cool. See, data ingestion is nothing but how you are loading the data into the environment. Like for example, my data may be sitting in Oracle, and I want to migrate that into a data warehouse which is in SQL Server. Assume that. So I need to first select the data from Oracle, and I need to perform some kind of data ingestion process into the like ETL staging area. In that area, we usually do the transformations and all, and then we try to load into the target data warehouse, which is a SQL Server or any kind of data warehouse. This is normal traditional ETL approach. But coming to big data side, we will go and need to use different frameworks here. If you go and see, now we have tools available, but in early 2000, if you go back and see, these tools people used to leverage frameworks. Like for example, for real-time streaming data, people used to leverage Kafka or Storm. For structured data processing, Scoop. For log processing, unstructured data, Flume. And machine learning, people used to leverage Spark, MLlib, or Mount. For data warehousing kind of stuff, people used to use Hive. And for data processing, people used to leverage Pig. And for orchestration and all, and scheduling, Uzi and Zookeeper. So data ingestion means how you are loading the data into the environment. So here multiple, for the data ingestion itself, we have like Scoop is there, Flume, Kafka, and all these frameworks. These frameworks people used to leverage on loading the data. Ingestion means loading the data. But now if you see,
Okay. So
Now
let
if you
me try
see,
to understand. So since
uh,
I'm not from the SQL, I have some
hmm,
questions. So
hmm,
for example, if you have on-prem data which is running on MS SQL or
hmm,
Oracle, something I have in on-prem. So
hmm.
if I wanted to work with the Snowflake, so I wanted to migrate all my on-prem database into the Snowflake and then I need to work, or is there any integration between those on-prem and the Snowflake, and then I can work with my on-prem?
Snowflake will never allow you to directly integrate with any other databases.
Okay. So in that case, we need to migrate entire data from on-prem to the
Correct.
Snowflake, and then we need to try running
Exactly.
this. Okay.
Even for migrating, you cannot directly do that. You need to have an
Mm-hmm.
intermediate cloud storage, like S3 bucket
Okay.
or
AWS
blob.
or Azure services we need to use for that.
Definitely, because even while creating the account, also they will prompt you which cloud
So
you
in
want.
that case, we need to first migrate the data from on-prem to the AWS from like
Correct.
S3 buckets, from S3 to Snowflake we need to do.
That is available, and we can
Okay.
also do with some other option is available like Snowpark, which is most recent invention in
Mm-hmm.
Snowflake. Without using cloud tools, also now we can do.
Okay.
But Snowpark is like we need to write some code in Python.
Okay.
You don't know Python, you can't
Mm-hmm.
use that.
Okay.
But on the alternative method, we can use S3 as a S3
S3.
or blob storage or Google Cloud Storage as intermediate storage, and we can
Okay.
first pull the data from Oracle to S3 bucket. From S3 bucket to Snowflake, we can automate the process.
Okay. Right.
So that is the data ingestion part, which is not directly done into Snowflake, but first
Mm-hmm.
you will store or pull into an intermediate like a cloud storage. From there, you will try to push into the Snowflake environment.
Okay. Got it.
So that ingestion will happen like that. But the transformations and all, we can use other tools which I was talking about, like Informatica, like
What
Material.
is mean by ingestion and transformation?
Ingestion means just loading the data
Okay.
as it is raw data.
Okay.
Transformation is what? We will try to convert the data into a form that is ready for my analysis. So assume I want to build a dashboard. I can't use as it is the raw data, right? I need
Yeah.
to pre-process the data and I need to
Mm-hmm.
bring into a form that is ready for some summarization. Like whatever I do in the transformation,
Mm-hmm.
I try to apply some filter transformation. So out of my 100 million records, I need to go and only like filter some set of like region data, Asia Pacific region, for example. So I need to apply some filter on that, right? Correct or not?
Yeah. Yeah.
My dashboard is only like looking for
Okay,
Asia
transformation
Pacific.
is something that, as per our requirements, we can transform that data into
Now
our.
we'll convert
Okay.
the
Yeah,
data.
okay.
And then that's what ETL, right? Extract, transform, and load. Extract is nothing but
Okay.
ingesting the data. Transform is you are converting into a desired form, and then loading is into the pushing the data into the target location.
So you mean to say ETL is replaced by, I mean, Snowflake now?
Not only ETL, we can say
Okay.
like ELT also, extract, load, transform as well. Not replacement, we can say it is just helping us to like automate the ETL or ELT without depending upon the any other cloud tools. Directly, we can
Okay.
perform all on the Snowflake data. We can go and leverage some tools available, or you can even apply the transformation inside Snowflake also. But you need to pay for that. We'll
Mhm.
discuss about that in detail, okay?
Yeah, sure, sure.
Yeah. So coming to like why Snowflake is very popular is first and foremost thing is simplicity. So simplicity means, but I want to go and create a Snowflake account within 2 to 3 minutes. I can go and create it. But normally, if you go and see any database, like I want to go and environment I want to create, it may take some time, right? Not immediately I can go and create. In the cloud environment, whenever the cloud came to the market, creating database servers became very easy. For example, to create a database, Oracle database server, I can go to AWS RDS and I can create within 5 to 10 minutes. And same case for other big data environments or other cloud databases also. So Snowflake is also fall under the same category. So creating Snowflake account will take 1 to 10, not even like 5 minutes, 2 to 3 minutes I can create. Simply it will ask you to enter your email, and once you enter the email, they will send an activation email to your Gmail or whatever. Once you receive that and click on activate button, it will prompt you to create your username and password, and they will generate a URL for you to access. That URL, ID name, password you need to use in the future, and that's it. Your account will be ready. Like how you create a Gmail account, right? Correct or not? Similar to that, I can create my Snowflake account also just by registering, and once my account is ready, I can start using it. So that much simple it is. And the scalability is another feature where I can scale up to any amount of data, any number of users, and any amount of workload. So there might be some restrictions on the scalability side in other databases. Suddenly my database will go down because there was no sufficient servers available, additional servers. But in Snowflake, you do not need to worry about automatic scalability will be there. Snowflake will take care of how to scale up and scale down the required resources. And elasticity, like size of the like Snowflake compute. So compute here means to run any SQL queries, we need some set of memory like resources like memory, CPU, temporary storage, all this, even in any other databases also. That compute part I can manage very easily in Snowflake because every Snowflake SQL query requires a virtual warehouse or compute to be continuously running to provide the CPU, memory, and temporary storage, all this stuff to run the query. This will be maintained by using a feature called virtual warehouses. These virtual warehouses will have a size like our t-shirt size, X small, small, medium, large, X large, like that. This size will determine how fast your queries will execute. So the size of the virtual warehouse can be modified anytime. It can be modified either like query is even running. So in normal other databases, I cannot run a SQL query when my upgrade is happening, right? Correct or not? If I'm upgrading the size of the database, can I run any queries in Oracle? Yes or no? In general, I cannot execute any queries. The database will be down, right? Because the compute and storage will be combined there. If you are adding additional servers, your database storage will not be available. If you are upgrading the storage, your database server will not be available. So the compute and the storage are coupled in other databases. But in Snowflake, both are not coupled, they are decoupled. So both are separate. I can increase the size of the database at any time. I can increase the compute also anytime. Both are not related at all. So that is one of the like finest feature in Snowflake called elasticity and flexible cost. So Snowflake allows you for pay as you go. You can use and pay. No need to pay in advance anything like other like databases and all. You need to go and use it and pay for what you are going to consume. So Snowflake will allow you to do that on a monthly basis. They will generate a bill and monthly billing you have to do. And also Snowflake is going to store your data in one single location and you can access from any device, any location, anytime. That is the flexibility with the Snowflake, and that is the reason why Snowflake is also very unique in the market now. But apart from this, what are the other features Snowflake is offering? So Snowflake is these are all the common like advantages compared to on-premise in Snowflake. Snowflake is a software as a service, just like a product. We can simply register, create a username, password, and log in and use it. Scalability we just now discussed about, and also like availability and security also is one of the popular feature where Snowflake is providing the security features and fast data retrieval, very fast. Even petabytes of data we can retrieve very fast in Snowflake. I will show you 10 terabytes table is there in Snowflake sample data, and we'll see how to go and run some query on that and how fast it will generate the output also we'll see. And the flexible charges, just now we discussed the pay as you go, and zero management and maintenance. As I mentioned, Snowflake team will take care of the maintenance of the Snowflake software. But in case of like big data environment or any Informatica tools, if you go in on-premise, as a team, the team has to take care of all these upgrades and maintenance, everything. Even you need to pay for the maintenance cost also. But in Snowflake, you do not need to worry about all this. You will, as a user, you will have a zero management. And Snowflake also provides some features like data sharing and data masking also to secure your data and near zero downtime And one interesting feature in Snowflake is time travel and failsafe. The time travel is one of the feature where you can restore your data even if you permanently deleted the data. But when I delete any data and save the changes, I cannot restore in other databases. If I drop any table also, I cannot restore that in the other databases because you need a backup also. If you don't have a backup, you will lose the data. If the customer data is sensitive and if at all you want to restore it, Snowflake will allow you to even restore the dropped tables by using a undrop command. So Snowflake advantages over other databases are like time travel is and also one of the very unique feature. And coming to like Snowflake other features, Snowflake follows standard ANSI SQL support. Whatever other databases are following, Snowflake also following the same SQL. If you learn, if you know, go and learn SQL here, you can manage other databases also very easily. And security and data protection also one of the very unique features Snowflake is providing, where Snowflake offering multi-factor authentication, federal authentication, single sign-on integration, all can be done in Snowflake by integrating with the like Snowflake environment. And the connectivity side, you have different connectors available: Spark connector, Python connector, Power BI connector, Tableau connector. Many different connectors are available to manage Snowflake data from the outside. And data sharing is one of the very unique feature available in Snowflake to share your data with other Snowflake accounts. So if to share any data, in general, we follow some traditional methods like FTP or email, sending as a attachment through email, or we store in a shared drive and sharing the access. But all this now you can eliminate. So without transferring the data, Snowflake is allowing to share the data with other people by leveraging the feature called secure data sharing. And this feature will give the security and data protection for your data, who is accessing your data. And along with this, we also can mask your data also. You can like hide your data. Dynamic data masking feature is providing that. To maintain your databases like dev, QA, similar replication to production, you can go and use zero copy cloning. Zero copy cloning will allow you to create multiple environments without additional storage cost. If I ask you a question, in Oracle database, assume we have a production environment with 1 terabyte database. If at all I want to create a database for staging and one for development, you need to definitely need to go and have additional storage cost of 2 terabytes. So in total, production plus staging and development all will consume 3 terabytes. But in Snowflake, I can avoid it. If my production is 1 terabyte, I can clone it to one staging and one development, and these two cloned databases will not consume any storage cost. So your storage cost will be zero if you go with a zero copy cloning feature. So this is not available even in other databases as well. So Snowflake, we can consider that as a data warehouse as a service. There is no hardware for us to select, install, or configure or manage. No like software is required to install or configure or manage. Ongoing maintenance, management, and tuning, everything will be taken care by Snowflake team in the background. We just need to log in and use it as a end user. That's it. That is what Snowflake is in at high level. And Snowflake also follows a combination of hybrid architecture. Normal traditional databases follow shared disk architecture. And modern databases which are in the market now, they are following shared nothing architecture, which means that you will have a separate storage for every machine. If you see here, in the traditional databases, what will happen in shared disk architecture, you will have one shared storage and multiple machines will manage to use it. If this is down, all this will be down, which means that this should be available to access this applications and all, because that is how the architecture was built, which is called shared disk architecture. But in case of Snowflake and the coming modern databases, they are following shared nothing architecture, which is nothing but you will have a separate storage. here if you see, there is a single storage and multiple nodes are managing a single storage. If this is down, all this will be down. But in case of shared nothing architecture, every machine will have its own storage. Even one machine is down, you will have these two machines. So like that, Snowflake is following a combination of hybrid architecture, which is basically will be fall under like a combined architecture, where you will get shared disk for easy to manage and shared nothing for speed and scalability. Snowflake is following both a combined hybrid multi-cluster architecture. So it is a hybrid architecture, so you will experience both features at one place. So this hybrid approach is not only provide the shared data and with the very cheap storage cost, and multiple compute clusters will be available to process your data, which is available in the shared environment. So Snowflake is following a combination of shared disk and shared nothing. So that too multi-cluster architecture, which will speed up your query execution speed also. So all the compute nodes will be accessed to the same centralized single storage. If it is a AWS specific Snowflake account which you created, all your storage will be maintained in the S3 bucket. If it is a Azure specific Snowflake account, all your storage will be maintained in the blob storage. If it is GCP specific, your storage will be in the Google Cloud account, Google Cloud storage. So all the compute resources will be maintained using the, if it is a AWS, your compute will be maintained using the EC2 instances. For Azure, the VM instances, and for GCP, we will have a also compute instances. So which means that Snowflake will try to leverage the corresponding cloud to maintain the data of the user and compute of the user. So which is following a hybrid architecture, and Snowflake comes with the three-layer architecture: cloud services layer, compute layer, and storage layer. The cloud services layer is responsible for how to go and manage all the metadata management, transaction management, access control. All this will be maintained in the topmost layer here. But here, query processing layer is the layer where your actual queries will be executed by leveraging these virtual warehouses. And the storage layer is responsible for how to store the data in an optimized way, that too in the form of like a compressed form. Snowflake will automatically compress the data which you are going to store in the Snowflake environment. So all this will be maintained by Snowflake in the background. We do not need to go and like maintain anything. And coming to like other features which you need to understand apart from this Snowflake architecture and all, let us try to understand the differences between the comparison between how Snowflake is different from other cloud databases. When you go back and see Redshift and Snowflake, both are competitors, but there are some differences where Snowflake is better than Redshift. The compute and storage in Redshift is bundled, combined. So you need to have the cluster to be running to access the database. But in Snowflake, that is totally separated. No separation of workloads in Redshift, but in Snowflake, we have a separation of workloads and storage. And to manage semi-structured data like JSON and Parquet and other like type of data, Snowflake can directly load semi-structured data into the table. But in Redshift side, we need to use a feature called Redshift Spectrum, which is a bit costly also. And coming to like performance perspective, Redshift and Redshift Spectrum are important to up. They should be running when you are using the like environment. But coming to like Snowflake side, the performance perspective, you do not need to worry. Snowflake team will take care of. And to build the particular or start your cluster, it will take minutes to hours to scale up and start any Redshift cluster. But in case of Snowflake, we can immediately go and start using it. No need to wait for hours and hours like Redshift. All the hardware and management cost will be taken care by Snowflake in the background. We do not need to worry. But in case of Redshift is AWS specific, so it is good for only AWS services, not for other tools available in the market. And this is about Redshift and Snowflake comparison. Similar to that, we also have like Teradata, Snowflake also the same issues. Teradata also similar to Redshift, which is having the compute storage separated, and the semi-structured data, if at all you want to maintain in Teradata, is very, very difficult. But in Snowflake, it is very easy. Plus, managing the data across multiple products is happening in Teradata, and that is the reason Teradata is slowly moving behind, and Snowflake is moving forward. And Oracle, Snowflake also having the same kind of comparison because both are very big competitors. But however, Snowflake is always winning in the competition because of its features, and backup and cost is very costly and time consuming in Oracle. And compute and storage are tightly combined. And there are some other like challenges in the maintenance side in the Oracle environment, but in Snowflake side it is not that much difficult. We can easily maintain because Snowflake will take care of that maintenance. And coming to like the architecture wise, this is one of the sample Snowflake architecture which you can see, where you will have some data sources, and here you are using the ETL process to ingest the data. But if you observe here, my data may come from any of the sources, but between Snowflake and these sources, we have S3 bucket here. Correct or not? I hope you know now you understood, Ranjit.
Yeah.
So this intermediate storage is important. Without this, I cannot directly load the data into Snowflake. I need to use this intermediate storage S3 bucket as of now here, and I can directly use this S3 bucket as a source and push into these particular tables by leveraging these particular features. And we'll try to discuss about what are these internal stage, external stage, and snow pipe and other features going forward. And other like architectures, if you want to understand, this is another architecture which is basically all my sources. Whatever you see, all these are sources. I'm integrating by using the Informatica here. The Informatica is one of the ETL tool which will integrate all the multiple sources. And here to push into Snowflake again, I am using S3 bucket only. Can you see that? This red circle where Informatica is pushing. Informatica is pushing all these sources into S3 bucket only. From here, I am again pushing into Snowflake. So which means that in any case, when you are willing to load data into Snowflake, you need to have an intermediate storage here. So as of now, S3 is the one which we are considering. And this is also same. My data, whatever you see, it is coming from a real-time environment. I'm using Python to like extract the data and pushing into S3 bucket here. And from S3 bucket, I'm using Matillion ETL tool to ingest the data. So Matillion is also one of the popular cloud ETL tool, which is like which are developed keeping Snowflake in mind. So it can help us to ingest the data from S3 bucket to one of the Snowflake environments, and where you are dividing into multiple layers here. So landing layer, like all these, whatever you see, these are all how you divide a environment in most of the ETL projects. You will have a like a landing layer to store the raw data as it is, and once my data is available, we'll try to process that using the data processing layer, and finally push into the semantic layer where your data will be available with some restrictions, and that data will be accessed by this particular analytical teams. It can be Tableau team or it can be a machine learning team. Whoever wants to leverage the data, they need to access through the semantic layer only. But semantic layer is accessible to Tableau team, but from semantic layer again, for ML team, machine learning team, we are generating another analytical layer also. All these will be under our control. But as a Snowflake developer, we need to know how to manage these particular different layers and how to maintain them in the project. And coming to like,
Okay.
yeah,
Now,
good.
where is the DBT and Airflow there? That architecture?
In the DBT place, we have Matillion. So
Okay.
Matillion is one of the tool which can do what DBT plus Airflow can do. So normally here you can use in the place of Matillion ETL, I can use DBT here. A DBT usually will be used not here, I mean, for the processing part and data modeling part. But here, Matillion can be used for even data ingestion also. Both it can be used for data ingestion and data processing. Because see, people why they going for DBT not Matillion is Matillion is a licensed version. You need to buy license. But
Okay.
DBT core is free. DBT cloud again licensed version, but people are leveraging DBT core to perform all these particular transformations and all this. And anytime they want to go and apply this particular data ingestion and all, they regularly we use whatever the tools we are using the same by leveraging the S3 bucket and independent storage. But when coming to the data pre-processing part, we have different tools to perform the transformations. So in the transformation part in the ETL process, all these tools which can process the data which is available in Snowflake we need like Matillion ETL transformation, DBT transformation, stream sets transformation, and also Colis ETL, 5tran. All these are developed for the transforming the data of Snowflake. So here, as of now, in this particular case, for the data ingestion, we are using ETL here Matillion. But here, what I am using? Informatica, right? Correct or not?
Yeah. This is for the ingestion. So
Data
in place
ingestion
of
only.
Informatica, it is coming Matillion.
Ah,
So now you're saying it can perform instead of Matillion, we can use DBT as well.
correct, correct. So you
So
can use
DBT can perform both like ingestion
no,
and
no,
the
no, 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 no. I'm talking about only DBT is basically used for transformations only, the T transfer transformations.
Okay.
But here, ingestion again, I need to use another tool. If you use Matillion, you can use both in one tool. That's what I'm saying.
Okay.
Here, I can use Informatica and I can use DBT here. Are you getting?
Yeah.
But this particular data ingestion can be done with any kind of tool, not only Informatica. So that is
No,
our
but
choice.
why DBT is popular now?
Because
If
open
Matillion
source.
is giving
Open
both
source.
the
Open
okay,
source.
open source. Okay.
DBT core is open source free.
Mhm.
Airflow is free. Python is free. So you should
So
understand.
DBT full form is data build
Data build tool.
transform?
Data build
Data
tool.
builder tool. Okay.
See, it is basically invented for data validations and data transformations only, not for data ingestion.
Okay.
But so because why people are running behind these tools, most of the companies are started using these tools is open source, the first thing.
Yeah.
See, if I ask you to buy a license for Matillion, nobody will be ready, right?
Yeah.
Because obviously. And Airflow is also Python related library.
Okay.
So to automate my activities and all, why I should go and buy a license because I already have open source tools which can fulfill.
Right.
So most of the companies who are affordable, they are using Matillion. We have tools available. See, not only for transformations, not only DBT, we have licensed transformation tools like Colis ETL, one new tool came in the market, 5tran, stream sets, many different tools available in the market in this space. Whatever you see here.
Okay.
I can use Matillion or DBT or stream sets or Colis ETL or 5tran, many tools available. According to your choice, you have to use that. It's not
Got it.
mandatory. I need to use only one tool. So every company has their own like uh, opinion, right, on the tool based on their experience. So every project will try to test these tools before, correct? According to their requirement, they will
Yeah.
try to select the tool which is required for their project. So in general, 80 to 90% people are going for DBT because it is open source and it is not that much difficult to write the code because all the DBT transformations are SQL queries only. If you know
Okay.
SQL, DBT also I can easily go and write the code.
Mhm.
So that is the reason DBT is popular. See, as a SQL developer, my job is to write SQL query means I can easily use DBT, right? Correct or not? Because my transformation is nothing but SQL statement in DBT. I just need to go and build it. How to go and run it and execute it. Those things as a SQL developer, everybody can go and do that. So
Right.
DBT is very popular because of that reason. And there are some other features also available. We'll discuss about that. But as of now, please keep in mind that these are all the different architectures with Snowflake end-to-end data pipeline. Okay. And coming to use cases wise, Snowflake can be used for the building a single enterprise level data warehouse. A data warehouse is nothing but which will have a historical data. If at all I want to go and build a data warehouse, I can do that and use that for my dashboard development like this, for sales analysis, inventory analysis like that. Coming to other use cases, I can even use Snowflake for like data lake management. What is my data lake? I want to go and build a credit card fraud detection. I need a live streaming data, right? For that, can I go and say a customer transaction is fraudulent after 1 week? Will the customer accept that suddenly? As a customer, will you accept your credit card you lost somewhere and someone is using it and you already called the call center and informed you lost the card and you asked them to block the card? But the team came to you after 1 week and mentioned there was a fraud transaction in your credit card. Will you accept it? No, right?
No.
Yeah, they have to block it. Similar to that, you might have experienced some recommendations in Amazon also when you buy any product. So every time you buy a product, they will send you recommendations, correct? Those recommendations, why you only receiving? Did any time you got a question in mind? When you buy any electronic goods, they will try to recommend you electronic goods, right? When you buy a laptop, they will offer you charger or headphones. How do they know that you are interested in these products? They will try to perform the live analysis. So they will try to capture your live actions, whatever which page you visited, which products you selected, all will be captured on fly. Then immediately they will try to see what you interested and they will try to send you some recommendations immediately. So they need a your live actions data or not, my question. Do you agree that why Amazon requires your live actions in their website? Because they need to provide live recommendations immediately on fly. So to build that, they need to build a big data lake. So we need, because Snowflake can be used for building a data lake also to build this kind of applications. Plus Snowflake will be used for many different purposes. Data loading. See, Snowflake is like offering a different clouds here. Amazon S3, Google Cloud Storage, Azure Blob Storage. And even from my local environment also I can load. If I don't have any of these cloud options, I can load from my local environment to Snowflake also. Snowflake will allow you to do. Assume that you don't have a cloud account, any cloud account. As I mentioned, we need intermediate storage, right? Correct? Are you getting? For the intermediate storage,
Yes.
if I don't have a cloud, I can use my local system also, right? Correct or not? Snowflake allow you to load from your local Windows or any machine to Snowflake environment by using some features available in Snowflake. And Snowflake also allow you to load all these file formats, CSV, JSON, most of these file formats available in the market with compression also. So these are all Snowflake is providing the customer to save their cost also. Compressing will save the cost, storage cost. So to load the data, I can use Snowflake internal environment using internal stages or S3 bucket, for example, by using a external stage also. We'll discuss about all these going forward. Okay. So I can build data engineering ELT pipelines, real-time recommendations when you are receiving from Netflix. Such kind of use cases I can build by using Snowflake. And data science and machine learning, which is very, very popular now in the market. Snowflake is offering data science and ML part also. So data science and machine learning, I can go and leverage Snowflake to even implement data science and machine learning. Snowflake is providing that. So I can build machine learning models also in Snowflake with some features Snowflake is offering. Snowflake AI Data Cloud is available. And secure data sharing, where you can share the data without transferring or emailing to other people. So that we go to and see in the bank, data security is one of the biggest challenge. So nobody will ready to share the data. So we need to go and find a solution to protect the data also. So secure data sharing will help us. But all these features, whatever we discussed about, most of these features Snowflake is providing. But however, how can I go and create a Snowflake account? And we'll try to see that. And these are the three example projects which we are going to discuss about in the training, where you can we'll go and build a end-to-end data pipeline by leveraging this particular AWS services with Snowflake end-to-end solution. The first one. Second one is also integrating multiple different sources and how to go and leverage S3 bucket, and finally push into Snowflake by leveraging the Snowflake features. And the third one is like how to go and extract real-time data and using Kafka, and how to push into Snowflake. We'll see that. And how to integrate with a dashboard tool also, we'll see real-time data analytics. And that is about what we are going to discuss about. And when you want to create a Snowflake account, it is not that much difficult. Simply need to go to Snowflake and open a URL like the sign up URL. And you can even search in the Google. They will try to share you the URL. Click on the URL. Once you click on the URL, you will be moved to this page. And you will see the, like for example, this particular details, you need to provide your own details. And you can mention whatever the role and the company name, all these details once you entered. And you observe here, it is providing a 120 days free trial period for 4 months. And if you go to normal method, you will get only 30 days. But the way how I am going to show you, you will get a 4 months free trial. That I am going to guide you how to do that. And once you give these details and click on continue, and you will be moved to the particular this page, 1 days trial period. And here you will see 3 different Snowflake editions: standard, enterprise, and business critical. You need to select appropriate one, and each edition will have its own features. Standard is basic level of edition. Enterprise is standard plus some extra features, and business critical is enterprise plus some additional features. So you need to select the according to the requirement. You need to select the edition. As of now, assume you selected enterprise edition, and next you need to select the cloud, which cloud you want. So you need to clearly select which cloud. Your company is using AWS, and if you select Azure, that is not the correct way. You need to find out which cloud your company already having an account, and try to use the corresponding cloud here. If your company is already having AWS account, use AWS here. And once after you finish that, check on this checkbox in the down, and once you click on the get started, then you will be moved to this page, where you will see your sign up is completed, and you will receive an email to the email which you mentioned, and that email will be like this. And you need to click on the activate button, and you see here in the down there is a URL available. This URL will be generated for you also, a unique URL. You need to keep it handy, and once you click on activate, that will ask you to enter username and password. You can also enter your own username and password, which you can easily remember. And once you click on get started, you will be moved to this page. And this is called as Snowsite web interface, which is a graphical user interface, and you will see a $400 free credit here, which Snowflake is providing. Plus 119 days trial period will be there. And then you can see here there are some sample SQLs available to test Snowflake environment. And you need to open a worksheet here, and that worksheet will allow you to run your SQL queries. That will discuss anyway. So what is needed to kick off your career in Snowflake is you should be a bit proficient in SQL, which we are going to learn, and some little bit knowledge about data warehousing concepts, which we are going to discuss about. And apart from that, you also need to know a little bit, any one database is okay, not mandatory, but if you know, that will be very helpful. And a cloud is not mandatory, because we do not need to be a cloud expert here. If you know at least one particular cloud at high level, that is fine, because we are going to use S3 bucket and some other services. So if you know that, that will be good. I am going to guide you anyway on that part. And coming to what are the prerequisites, because we already mentioned, we need to go and need to understand about SQL. where that will help you to go and learn Snowflake faster. And cloud awareness, I'm going to guide you. And familiarity with ETL and data pipelines also we'll discuss about. Very, very basic level of scripting also needed, but I'll guide you on that as well for Python side if needed. So most of these features, whatever you see, this we'll learn. We will learn step by step, day by day, with accumulative nature. So every topic we'll learn and we'll try to integrate with next topic with all use cases and examples and assignments, and also with some interactive quiz I am going to share you on a daily basis for every topic which you can go through. With hands-on scripts you will be going to receive and assignments as well. Plus you will get a daily recording in the Google Drive. All you will be going to receive every day after the class. And at the same time you need to practice as well. If you don't practice, you can't learn. That is what I can advise. And coming to like other tools in your career, on after learning Snowflake, which tools you need to learn to move your career in the ladder is you can learn any one of these tools. We are already learning DBT here. So if you learn DBT, that is more than enough. If you want to learn any other tools, Matillion, Stream Sets, and we also have tools like Fivetran, CoolCTL also, and Stream, which you can explore later. But we are going to cover DBT, Snowflake, AWS, and Airflow as well. And the Snowflake side, if you see the job market, it is growing. Starting, if you see when they started in 2015, now you see how it is running and how it has been increased year by year. Most of the jobs are now coming with Snowflake with AWS and DBT combination with Airflow only. And whatever we are going to learn, this is a task-based training and a project-oriented training, not like normal training. Any questions?
So, if we are learning Snowflake, is there any need to learn something additional services along with it?
As I mentioned, right? Additional services in the sense the tool-wise DBT and Airflow. These are very popular. We are going to learn these tools also along with Snowflake. And coming to like AWS side, S3 service we extensively use, and which are going to also learn and how to use S3 during the data loading part, and some part of like Snowpark and Python integration also we will go and learn, because some companies are asking for Snowflake with Python and Snowflake with the Spark integration. So these particular features like a Snowflake Python connector, I used to teach in earlier batches, but Snowpark, this is the most recent 2 to 3 batches only I'm covering. That is also very popular now. So Snowpark with Snowflake is also which is going to help you to reduce your cost. So I'm even covering that as well.
Now, for example, when we learn Hadoop, so we also need to learn like core services in that, like HDFS, Yarn, Peak, and as
Exactly.
well as security tool like Kerberos,
But here the features
SSMTLS.
are integrated, right, inside Snowflake.
Uh, uh,
So in Hadoop side, your frameworks are separate. That's what I was telling you. To become a big data engineer, how many frameworks you want to learn?
yes,
You know the
yes.
pain, right? Even I learned.
Yes.
Even I learned all the frameworks when I worked in the big data project in MasterCard. My journey started learning MapReduce and HDFS, and later it scattered to multiple different frameworks. Now, to learning Snowflake, if you learn Snowflake, everything will be integrated in single product, right? Correct or not? No need
Yes.
to learn different like services here. Snowflake itself contain all features inside, integrated. Only to perform
Okay.
some kind of transformations only, we are leveraging DBT. And AWS anyway as independent storage. And Airflow for orchestration, that's it. That too because Snowflake
So,
orchestration framework is there, like task. Since task having some limitations, people are moving to Airflow now. That is the only reason. If the task will become like Airflow, no Airflow also is not needed at all, because they are still emerging, right? It will take some time.
so
Hmm.
Is this course focused on Snowflake admin or developer role?
It's a combination of both, Shoaib, because
Mm-hmm.
development, see, when you want to go and learn admin, you should be a developer first, right? Correct or not? As a
Mm-hmm.
developer, you should know some knowledge on development side, and then you can become administrator. That's what even if you go to Oracle, a administrator should know development, a developer should not know administration. Correct or not?
Yes, but as
Hmm.
of now, because however, I learned previously when I getting a job before, so I go with the big data Hadoop admin, and after that I switch to Kubernetes admin. But both the scenario have like
Hmm.
big data developer as well and Kubernetes developer as
Agree,
well.
totally agree. That's what I'm saying.
Yes,
They
yes,
are all
yeah.
tool based, right? Tool based, and
Yes, yes.
but this is not specifically tool based, right? This is like a
Mm-hmm.
product based and database specific. See, the Snowflake is a data warehouse, correct? No,
Mm-hmm.
as a data
Yes.
warehouse, a database. So first of all, I should understand what are the fundamental concepts of database in Snowflake. But most of them are SQL part only. But if you know them, that will make your life easier. Correct or not?
Mm-hmm. Yes.
So administration, if you want to learn, even if you go and I want to become a Oracle DBA, I cannot
Mm-hmm.
become Oracle DBA directly. I need to know the normal SQL commands first, and then PLSQL, and then I need to go for a DBA activities later. The same concept here also. Hope you are getting.
So yes, so because I'm not interested in the coding side, so I don't have the coding, so that's why I'm thinking. So will I
See, even
proceed with it?
admin side, see, even admin side also, see, coding in the sense, see, here, Snowflake environment itself will have some like plug and play. Earlier, we
Mm-hmm.
used to write coding and all. Now we are not writing any coding to create a database. Like for example, let me show you. To create a database, earlier I used to go and run command create database name. Now if you go and see, Snowflake is offering to create the database directly in the environment with some plug and play. We do not need to write a code also. Directly go to Snowflake and
No, sir.
uh,
No, sir. Just SQL related is enough, but heavy coding is not involved in the
no,
fully.
there is no heavy coding involved. That's what I'm saying.
Yes.
See, extreme use cases only we use Python. Okay. See,
Mm-hmm.
if I'm willing to do some data pre-processing at a high volume of data, and most of the data is sitting in big data side, then definitely I need to connect, right? Correct or not? My source
Yes.
in big data, I cannot go and say that I can't connect. No, I need to connect. In
Yes.
that case, if my data is sitting in some S3 bucket and all, if needed, I need to connect with Python. But that
Mm-hmm.
part at high level, you should know how to do that. Because the companies will not going to accept if you don't know even Python now. No, because Snowflake, they're especially some companies are looking for Snowflake with Python integration also. Some companies, because if you
Mm-hmm.
know, right, if you learn big data, how Python became mandatory now. Correct.
Yes.
If you don't know Python, you can't even manage any of the tools. Every tool now it is having a requirement of Python in every particular course. I teach Python, to be honest. Without
Mm-hmm.
Python, the day we can't start and end. That's what happening now. Every tool now Python is mandatory. So in every class, I will have a Python module, including
Mm-hmm.
Snowflake or wherever you go. So you cannot skip the Python because some part of Snowflake Python connector, there you will automate some of the activities of running Snowflake commands from Python. In that scenario, 1 to 3 classes, I will show you how to use Python also. If needed, only how to use it. It's not mandatory.
Mm-hmm.
Even Snowpark also. See, I'm teaching this because these are very advanced concepts where some companies are looking, and most of the people does not even teaching and does not even know. Hope you are getting.
Mm-hmm. So Snowflake and also the data engineer both are different concept. Am I
See,
correct?
Snowflake is a environment. I can implement data
Mm-hmm.
engineering in Snowflake. See,
Mm-hmm.
so both are
Okay.
same. Snowflake data engineers, we call them as, right? Big data engineer. How you call it as a big data engineer or AWS cloud data engineer? Snowflake data engineers will create the data pipelines inside Snowflake. But in big data side, you will create in big data environment, right? Correct or not?
Mm-hmm.
But there you use some kind of coding like PySpark and other Python coding or Scala coding, but here you maintain using the SQL statements. That's it. See, most of the code will be in SQL part here, ANSI SQL, that too.
Yeah, but earlier you mentioned like data pipeline. So data pipeline is related to like DevOps, like CI/CD, or
Correct.
is it different, or is it
See, I
different?
can see DevOps. If at all I want to implement, I have tools available which can integrate with Snowflake. DataOps tool is there, or you can, if at all you want to integrate your DevOps knowledge to Snowflake, also you can do that. But that is not mandatory now. So DataOps is very very like uh, advanced. Not yet every company is using that now in Snowflake.
No,
Everything.
no. I tried to learn the CI/CD pipeline from DevOps, but it's very complicated.
Hmm.
So somehow, just I want to confirm from your side,
Hmm.
whenever we are going to create a data pipelines in Snowflake.
Hmm.
So is it the way to create the same way, or is
No,
is
no,
it
no.
having a
There
different
are
way? Yeah.
no any
Mhm.
DevOps involved in Snowflake environment. Nothing is
Mhm.
required. For automating
Yeah.
and all, we
No,
use Snowflake.
creating while creating pipeline is different method using for Snowflake.
Correct, correct. One of the easiest method compared to what
Yes.
already in big data you are doing.
Mhm.
You need to write so much of coding, right, in big data side.
Yes, big data and DevOps as well.
But here you do not need to write any code and all. That's what I'm saying. When you log in
No,
inside, you
even
can.
in the
Hmm.
even in DevOps, so whenever we are going to create pipelines for CI/CD pipeline,
Hmm.
so we need a coding like Python, or maybe
Correct.
can go with
That's
the
what I'm saying.
Terraform as
Here
well.
we do not
Hmm.
need Python at all. I can implement using everything using the stored procedure also.
Hmm.
Snowflake stored procedure I can write. I can go and leverage that. I can create my pipeline also. I can schedule that.
Hmm. Hmm.
So anytime you want to go and run any like automations on only people are using Python.
Hmm.
See, if I am a Python programmer, I'll definitely use Python to automate my stuff in stuff using Snowflake environment, right? Before pushing into Snowflake, because I want to save the cost. First thing,
Yes. Hmm.
people who look for people who can reduce the cost also. No, in that particular scenario, definitely you need to think about alternative methods, but not every time. But in my case, I am a big data engineer and Python core developer. I use Python for most of my activities on a daily basis to manage even Snowflake also. But I never force anyone to do that. But to make my life easier, I do that. Hope you are getting.
Hmm. Yes.
So this is what the Snowflake environment, what you see
Hmm.
here. This is called Snowsite interface. To create a database here, I can simply go to databases and there is a database button here. Simply give the name like demo and click on create. See, automatically the database came. Can you see that?
Hmm.
So we are not
Yes.
writing any commands here. Hope you are getting.
Hmm. Hmm. Yes.
I can get a schema also. Simply go and select and give dev schema. See, that came automatically here.
Hmm.
See,
Hmm.
I can get a table also. So see, automatically when schema is selected, table is coming here. See,
Hmm.
I can create from a file, select from a file,
Hmm.
and create the name as employee. EMP, I'll give the name, and the file I'll select from here. Browse. See, all these we can we can write even through coding also, but I don't want to do that. I just want to upload the file. So what I will do,
Hmm.
I select the file. And once the file is uploaded here, simply click on next. See, automatically it will select what columns are there in the file and the
Hmm.
corresponding data types. The schema detection it will do automatically. And then simply click on load and the table will be created with 1000 rows. See, did we write,
Yes.
did we write any commands now?
No.
No, that's what, see, data also automatically came.
Hmm.
See, that is what, see, everything is tool based here. Sometimes
Hmm.
to automate the data pipelines, you definitely need to write a SQL script. The SQL
Hmm.
command definitely you need to write, right?
Yes.
Those things we can't stop. to be honest.
Mhm.
Because if you feel that SQL coding also difficult, then it is not difficult, I feel. See, compared to
No, no,
Python
not
coding,
difficult. But
uh,
mm, even though
even for
suppose.
administration also, Snowflake
Mhm.
administration also, you have to write some SQL queries. Because
Mhm.
to monitor the database as a DBA, you need to write some SQL queries, right? Correct or not?
No, yes, yes. No, because earlier whatever we perform over the Linux, all those
Mm,
stuff like
mm,
related to
mm.
scripting and command line, but
Shell scripting. You write shell
shell
scripting.
scripting, shell scripting, but somehow we have to create the database for to integrate. So there was a small database, not in a huge amount of just
Correct. Agree. But
yeah, for
here,
user
everything
and
will be here.
mm-hmm.
Everything will be done through SQL commands only.
Mm.
Nothing more.
So if you want to proceed with this course, so we
Mm.
have to first learn the skill, or you will cover
I will
this all
teach.
those
I
stuff.
will cover SQL part also.
Even though I don't, if we don't have, if you have zero knowledge of SQL.
Correct. I will start from the
Yes.
scratch only because most
Mm-hmm.
of the people, because like Ranjit also was
Mm-hmm.
requesting for SQL commands and SQL course,
Mm-hmm.
and I'm covering SQL part also,
Mm-hmm.
and data warehousing fundamentals as well, which are the prerequisites for this.
And so last question,
Hmm.
how many years of experience can we show after completing of this course?
See, minimum 3 to 5 years, I suggest, because everybody
Mm-hmm.
is looking for minimum 3 years and maximum more than that. But we can't go more
Mm-hmm.
than 10 years because Snowflake came very recently only, right? So,
Yeah.
so you can just showcase up to 4 to 5 years will be very good
Mm-hmm.
based on our
Sir,
experience.
sir, earlier I mentioned in my introduction, so I
Hmm.
have total 6.5 years experience. So
Hmm.
relevant, I can show 2.5 or 3 years. Okay.
3 to 4,
So,
3 years will be good. 3 years will be good.
okay. Hmm. And can I face the challenges because since last year I'm not working. So while getting a job, I will face the challenges, or I need to add manageable documents with the other company.
My advice is manage it because in
Uh-huh.
Indian IT industry, right? You know, right?
Uh-huh. Uh-huh.
They instead of looking at the technical side, they do more on admin side.
Uh,
So my advice is manage it. If you are unable
okay.
to find any solution, let me know. I will
Hmm.
guide you. Some people are there for that.
So, sir, I'm basically from Maharashtra.
Okay.
So I was thinking to come tomorrow Hyderabad.
Okay.
So, is it possible to meet
Me,
physically? Uh, huh?
difficult because I am
Hmm.
currently located not in as of now in Hyderabad. I'm in UK.
Okay.
Yeah,
Okay.
that is the reason. We can have a
Okay.
video call. That's fine. No problem later.
Uh-huh.
Not a problem.
Because Ranjit is also from, I think, Hyderabad, or is
Ah,
yeah?
No, no, I'm from
Huh?
Bangalore, but I'm in native,
Hmm.
which is in Andhra.
Hmm. Okay. Okay.
Yeah.
anyway, we'll talk.
Hmm. Hmm.
So
So
not a
yeah,
problem.
yeah, yeah. So somehow I have some other query. So just
Hmm.
before I proceed to with the course, so just I want to
Hmm.
clarity on that. Then after that we can proceed.
No
So
problem.
this class will be only online for not for offline. Okay.
Correct. Online only. 6 p.m. IST the timings.
Okay. So only we suppose if I proceed, so we will be only two people, Ranjit and me, and
No, no,
other
no.
will.
Pujita is there, and one more Suhasini is there, and one more guy
Mm-hmm.
Nikhil. They are
Mm-hmm.
also will be part of that training.
Okay. Okay, sir. Okay.
Okay.
Nice to talk with you. Thank you for the times.
No
Thank you, Ranjit. Thank you.
problem. Okay, that's
Okay,
all,
thank you.
Ranjit. I hope you
Yeah.
got some idea also. So I'll share this particular recording and I hope you got the course curriculum, right? Both of you.
No, yes, but if you can show once more on the screen, so we will get satisfied.
Let me show you.
I have one more query, Sri. So
Hmm.
I could see your WhatsApp communication channel that it offers many courses, right? Like Python or DevOps, Azure or
Correct.
something.
Correct.
So will you be teaching that, or who will be taking care of that? Or you're
Some I
saying,
teach, some I have some partners,
oh, okay, fine.
but I'll be the point of contact for everything.
Okay, okay, that's okay.
Yeah, yeah. Because I have five
And
communities, not one community.
Mm-hmm.
So all 5
So
communities I maintain, and I
Okay.
am a like a Snowflake, not only Snowflake architect. I am a big data engineer. I worked as a data scientist, so I manage multiple
Okay.
technologies. So I give trainings on most of the technologies,
Oh.
80% of whatever I mentioned, and 20% which I don't know, I go with the other partners. So
Okay.
you can see the curriculum, right? So
Yeah.
basically this is a 40 hours course, and where we start with the introduction of Snowflake and try to understand whatever we discussed today as of now at a high level, also the introduction only. And we also saw how to create a Snowflake account and what are Snowflake editions at high level. And we also saw the Snowflake web interface also. And after that, we'll try to see how to understand about Snowflake RBAC, and then how to manage Snowflake environment with role-based access control. And there are different types of accounts available. We'll discuss about that also as part of this particular first module. Second module, we'll try to understand about how Snowflake can be managed with the S3 storage. We'll discuss about that. And in deep about architecture and what is the Snowflake query history tab and all this we'll discuss about. And you also need to understand about Snowflake pricing, how Snowflake is going to charge. That is very important. And we should understand how Snowflake is going to charge and what is the pricing methods. We will try to understand about that. Along with Snowflake pricing, we also will learn about Snowflake caching and virtual warehouse management. These two are very important to reduce how to reduce your pricing also, the cost also. That part we will learn about this particular second module. Third module is where the very, very important module on data loading part. How to load the data and how to unload the data from Snowflake. So how to load data into Snowflake, and we can also export the data from Snowflake outside also. Though that particular like features will be discussed in this third module, like from how to load from local to Snowflake or S3 bucket to Snowflake, or how to export the data from Snowflake to local or Snowflake to S3 bucket back. So we will learn about all this stuff in this particular third module. Fourth module is mainly dedicated for how to manage the semi-structured data in Snowflake, where Snowflake is offering on the data loading part. In the data loading, we have bulk loading and continuous loading. We will try to do all bulk loading in this module with different file formats. Then we'll move to the continuous loading by using SnowPipe. How to automate data loading by using SnowPipe, we'll try to see that. And then we'll move to the partner connect with Snowflake, how to connect different connectors here, like Python, DBT. I will try to show you with how to manage with Power BI and the stream sets. And I show you every important connectors which I worked on, and I'll try to guide you on that. And the seventh module is scheduling in Snowflake, where we go and see the incremental loading and scheduling by using the streams and tasks here. Both will help to perform the incremental loading by scheduling that. And the eighth module is on the data governance, secure data sharing, how to share the data between multiple Snowflake accounts and non-Snowflake accounts. And then we'll try to see data masking also. Data sharing here. And then we'll move to the cloning, zero copy cloning, and where we'll try to create multiple Snowflake environments with zero additional cost. That part we will try to learn in the cloning, or zero copy cloning. The next part is time travel and failsafe. How to go and leverage time travel and failsafe to restore your deleted data. Because whenever you delete any data, you can't restore it in other databases. But in Snowflake, time travel and will help you to restore your data. And how to restore your data, even time travel if it is expired, that is where failsafe will come into picture. That we learn as part of this particular module. And also how to perform the data governance using Snowflake views, how to control the data access, what are normal views, metless views, and secure views. We will try to discuss about all this stuff. And then we move to the clustering and micro partitioning, and how to manage cluster keys, and how to improve the query performance optimization, we will discuss all this as part of this particular like a clustering and performance tuning method module. And also, finally, I'm covering Snowflake Python connector and Snowpark API, and both I'm covering in detail, which are very important. Then we move to the user-defined functions and store procedures, and which are very also important in Snowflake to manage the data. Then we move to the DBT with Snowflake and try to learn how to manage end-to-end data transformations using DBT and Snowflake. We also will do some use cases like end-to-end project in Snowflake DBT. Then we'll move to the Airflow and Snowflake integration, where we'll see how to manage Snowflake using Airflow orchestration and DBT integration. And finally, we also will learn about these particular projects, whatever you see. These 5 projects are majorly will help you to manage the Snowflake environment, and additionally, we also will learn some part of like admin activities also. That admin activities are not part of this. There is one more uh, like document is there. Let me open that and show you. The administration side, we have some set of topics available. So here we by the time we finish the development part, you will become a Snowflake developer. Then you need to go and explore more on the Snowflake architecture side. So we will try to see in detail about what are Snowflake admin roles and responsibilities. Also, we'll try to see how to manage the virtual warehouses and how to go and scale up and scale down and monitor the virtual warehouses. These are all the responsibilities of a administrator. So we will try to learn how to manage the compute and then how to go and manage the Snowflake objects, and also how to learn some of the commands which are related for managing Snowflake environment at admin side. We will try to learn as part of this particular module. And fourth module is basically like what are the issues you will encounter in the data loading side and how to support the development teams when they encounter any data loading issues. We'll try to discuss about that. Then we'll move to the like transaction management and what is clustering, and also like table versioning. All we'll learn about this particular fifth module. Sixth module is dedicated for time travel, zero copy cloning, and how to maintain the backup, restore, and snapshot in public environment. Then we move to the storage management and how to create multiple different types of tables like permanent table, temporary table, transient tables, and newly Snowflake got hybrid tables and iceberg tables and event tables also, and we got directory tables and external tables. So we'll try to discuss all these at storage level. Then we move to the performance perspective. We have like a query profile analysis and how to understand a query, how it will be like managed, and how query planning will be generated, and how to use different features like query acceleration service, search optimization service, how to optimize your query execution. We'll try to learn and also see how to leverage message views to manage the Snowflake SQL queries. Then we'll move to the RBAC also, which is one of the important tasks for administrator on Snowflake RBAC. And then we move to the resource monitoring, how to monitor the Snowflake warehouses to get notifications when the credit quota is reached, and how to go and manage the compute and monitor that. Then we move to the secure views and secure UDFs to manage the security and data governance as at admin level. Then we'll try to see some of the best practices on how Snowflake administrator need to work on like across organization level and account level in Snowflake, and how to go and manage the entire environment with some best practices. Plus, I also will share some of the common SQL like queries which required for administrator to manage. And along with this, we also will see some part of like some use cases, how a administrator will manage Snowflake environment. And I'll also show you some automation which we can do to manage Snowflake environment admin side. That also I'll cover. Got it?
Okay.
Yeah, these are all we are going to learn.
So when we'll start the SQL? First with the SQL or with the Snowflake content only?
So we will learn some part of basic SQL, basic Snowflake, which is not needed SQL part.
Okay.
Like pricing, all this does not require SQL anyway.
Mm-hmm.
So we learn all those stuff and then we'll move to the SQL part and data warehousing part.
Okay.
Okay?
Yes. Okay. And you will focus only mostly on the AWS or both the
Only
AWS or
AWS.
Azure?
Only AWS only. Because so Azure side, I worked on that, but most of my batches are in AWS only. If you want any assistance on Azure side, I will share. I have some automation, some scripts are available. Whenever I teach AWS, you can also use Azure side and you can test it. I will share whatever required for that.
No, because you are in the current market, so as you know better than me, so I
And
was
AWS
just
only.
asking the question.
AWS,
Yeah.
AWS only. AWS is on top.
Okay. Mhm. So
Azure is
this content.
Azure came most recently only, no?
Yes.
Hmm.
So this content is will cover within like 40 hours. So daily will be how much time will we take, or this will.
Daily 1 to 1.5 hour. It may go up to 50 hours, not 40. More than
Okay.
because it need to be like 40 hours, but it go up to 50 hours because both need to be covered, right? I'm saying
Yes.
approximately 40, but it go up to 50 hours because of the projects also.
Okay, sir. Okay. Thank you.
Okay, then that's all for today. And
Yes.
we are going to start tomorrow at same time, 6 p.m. And you can just join and uh, get some knowledge on how the pricing and all I'm going to discuss tomorrow. Okay?
Okay, sir. So thank you. Thanks for
Thank
the
you.
time.
Thank you.
Thank you.
Thank you.
Thank you, Shri. Thanks for
Thank you.
explaining.